Okay, get this. You've given us a dictionary from, well, February 1997.
The University of Alberta's Cognitive Science Dictionary.
Right, right. But think about it. It's like a time machine, frozen right before, AI and neuroscience really took off.
It is a fascinating snapshot. Some of the entries, like the debate on cognitive
Like
penetrability,
cognitive penetrability.
yeah, are surprisingly relevant even today. Back then, they were grappling with whether our thoughts are really independent of our beliefs. It's a question that's, well, central to a lot of modern discussions about bias.
Wow. They were already thinking about that back then.
Absolutely. And then there are entries that really show just how much our understanding has, well, evolved. Take connectionism, for instance.
Connectionism.
Yeah, in 97, it was this emerging model of how the brain learns, like a web of connections.
Okay.
But today, it's, well, a cornerstone of artificial intelligence.
It's like they were laying the groundwork for a revolution without even realizing it.
Yeah.
So where do we even begin?
Let's start by, I guess, mapping the terrain. The dictionary covers everything from memory, learning to language, AI, even humor.
Humor.
Yeah. You can really see the scope of cognitive science back then.
I wouldn't have expected to find humor in a cognitive science dictionary. That's interesting.
It is. It's a good reminder that cognitive science is about understanding the full spectrum of human thought. And if you look closely, some letters, well, they're missing entries.
Ah, okay.
It's like a puzzle with some missing pieces.
Okay. Let's jump into some specific entries. What stands out?
I think everyone's seen a baby, trying to grab a toy, right?
Yeah.
Piaget used that very example to explain assimilation and accommodation,
Okay.
two key concepts in how we, adapt to new information.
Right, right. The baby tries to understand the new object. That's assimilation.
Yeah.
But then has to, change their understanding. That's accommodation.
Exactly. They might try to grasp a rattle the same way they grasp a block, but then they find out, oh, it makes noise when I shake it, so they have to adjust their actions.
Like they're updating mental software, right?
And what's amazing is this process, it doesn't stop in childhood. We're always assimilating and accommodating throughout our lives as we learn, encounter new things, or, just navigate a world that's constantly changing.
I'm thinking about how I had to adapt to, all the new technologies over the years.
Absolutely. Our ability to adapt really shows the plasticity of our brains.
Speaking of challenges,
Yeah.
the dictionary entry for Alzheimer's disease is pretty, well, stark.
Yeah.
The statistics from 97, 5.1% prevalence in Canada for those 65 and over are, well, pretty sobering.
It is a reminder of the impact of this disease. Imagine how that number has changed, with our aging population. But it's also important to recognize the progress made in Alzheimer's research since 97. We understand more about, the biology, and new treatments are being developed.
That's good. That's good to hear. Okay, let's shift gears a bit. I'm curious about the entry for analogy and how it connects to problem solving.
Well, the dictionary uses this kind of quirky example from Barcelou's work in 92. Imagine someone describing an office complex as, well, being laid out like a starfish.
A starfish?
Yeah.
Okay. How does that even work?
Well, it might seem odd, but by making that analogy, you're taking what you know about a starfish with its central body and arms and using it to understand the layout of the office complex.
Okay.
Creates a mental picture.
I see, I see. It's like our brains are constantly trying to find familiar patterns. But isn't there a risk with analogies, like taking them too far?
Oh, absolutely. There are limits. As Barcelou points out, we wouldn't assume the office complex, is alive or lives underwater just because it looks like a starfish.
Right.
Our brains have to see where the parallels end.
It's a balance between thinking creatively, but also thinking critically. Right.
Precisely. Now, let's look at something a bit more visual. The entry on apparent motion.
Apparent motion.
It sounds complicated, but I have a feeling it's something we see all the time.
Think about flip books or those old dot matrix animations. You see static images, but your brain perceives them as motion.
Oh, right. Like those stick figure animations.
Exactly. Your brain fills in the gaps, creating the illusion. It's the same principle behind video games, movie special effects, even scrolling on your phone.
Wow. So those simple animations were tapping into something fundamental about how our brains work.
And it shows how much of what we understand about the mind comes from visual illusions. And as neuroscience has advanced, we can now actually pinpoint, the brain areas involved. Like we can see the illusion happening.
Amazing. Now, I'm really curious about how they defined artificial intelligence back in 97. I bet it's pretty different from the AI we have now.
Yeah, you're right. The dictionary talks about AI as, creating computer programs that can do difficult cognitive tasks. But even back then, there were different approaches. Some focused on mimicking human cognition.
Others just wanted to create programs that could solve problems regardless of how humans do it.
So those two
Hmm.
paths, like mimicking us versus just creating intelligent systems, were already there.
Exactly. And one key difference the dictionary highlights is how computers and brains processed information. Computers back then worked step by step,
Yep.
while brains were doing millions of computations simultaneously.
Ah,
It's that serial versus parallel processing that Churchland wrote about in '89.
I'm starting to see why AI seemed so, well, limited back then. It's like comparing a single-lane road to a superhighway.
Yeah, good analogy. And even with all the progress we've made in AI, machines writing poetry, composing music, diagnosing diseases, we still haven't cracked the code of consciousness,
Right.
or truly replicated all of human intelligence.
Which takes us back to connectionism. Did this idea, of the brain as a web of neurons, did that play a role in AI?
Absolutely. Connectionist models, also called neural networks, are a major part of modern AI. They're great at things like pattern recognition, language processing, even decision making.
Okay.
It's that spider web analogy in action.
So are these connectionist models a better representation of how our brains work compared to the older symbolic AI?
Well, it's not that simple. Both approaches have their pluses and minuses. Connectionist models can be hard to understand, like black boxes. They excel at learning patterns, but struggle with abstract reasoning, something traditional AI is better at.
So it's not about one being like superior, but using the strengths of each.
Exactly. The future of AI is likely a combination of both.
Okay, now for the big one, consciousness. Does this dictionary even try to define it?
It did, and in a way that reflects just how complex the debate is. It gives multiple definitions, highlighting how elusive consciousness is. One focuses on awareness of our mental processes, a more traditional view, and then there's Minsky's perspective from '85, which is, a bit more radical.
What did Minsky say?
He suggested that our conscious experience, it lags behind the actual events in our brains.
Oh, okay.
We're always a bit behind, experiencing a delayed version of reality. And he attributed that to the limitations of our cognitive systems, the time it takes different parts of our brains to talk to each other.
That's a mind-boggling concept. So are we still like struggling with this idea of consciousness?
In many ways, yes. We've made progress in understanding, the neural parts of consciousness, but the feeling of awareness, the what it's like, that remains a real mystery.
It makes you realize how much we just don't know about our own minds.
It
Yeah.
does. And this leads to something that affects all of us, how our cognitive abilities change as we age. The entries for crystallized intelligence and fluid intelligence provide a framework for understanding that change.
Okay, tell me more.
Crystallized intelligence is our accumulated knowledge and skills, like the wisdom we gain.
It's that feeling of having a deeper understanding as you get older.
Exactly. Fluid intelligence, on the other hand, is our ability to think on our feet, solve new problems, and adapt. It's mental agility.
And this is the type that declines with age, right?
Yeah, unfortunately. But the good news is research suggests we can maintain and even improve it. Staying mentally active, learning new things, challenging ourselves.
So it's not inevitable.
No, no. And it all comes back to that idea of lifelong adaptation. Our brains are really amazing, capable of change throughout our lives.
Okay, before we finish up this part of our deep dive, let's talk about Piaget's stage theory of development. It's interesting to see how he mapped out how children's thinking changes.
Right. The dictionary gives a nice overview of Piaget's 4 stages. The sensorimotor stage, where babies learn through, senses and actions. The pre-operational stage, where language and symbolic thinking emerge. The concrete operational stage, where logical reasoning develops. And finally, the formal operational stage, where abstract thinking takes center stage.
It reminds me of watching my niece grow up and go through those stages. It's really amazing how children think and learn.
It is. And while there's been debate about Piaget's theory, some argue that, that development isn't as clear-cut as you said, that it's more continuous and influenced by individual experiences.
So the stages might be up for debate, but the main idea of like a progression from concrete to abstract thinking, that still holds up.
Yeah. Piaget's work really changed how we think about children's minds. It still influences research and education today.
It's remarkable how a theory from decades ago can still be so So relevant to understanding the human mind. Okay, so uh, we've gone from a baby grasping a toy to the complexities of Alzheimer's and AI.
And we're not done yet.
Okay.
There's another entry I think you'll find interesting, linguistic determination.
Oh yeah, the idea that like the language you speak shapes how you see the world. That's
Yeah.
a classic debate, but I'm curious to see how they tackled it back then.
Well, the dictionary brings up that, that classic example, the Eskimo words for snow.
Oh, right. The idea being that because Eskimo languages have all these words for different types of snow, well, they actually perceive snow differently.
So, like, instead of just seeing snow, they see powdery snow, crusty snow,
Right.
or whatever.
Exactly. And it's like their language gives them a more detailed view of the world. Does the dictionary, does it say if this actually holds up? It really gets into the heart of the debate. There are strong and weak versions of this idea.
Okay.
The strong version says language totally determines thought,
Okay.
and the weaker one suggests it influences it but doesn't completely control it.
So it's kind of like a nature versus nurture, but for language.
Right. And the dictionary points to research that supports both sides. There are studies that show speakers of different languages do perform differently on certain cognitive tasks, which suggests language does have an influence. But then we also know we can think about things, even if we don't have words for them.
Yeah, like when you have a feeling, but you just, you can't put it into words.
Yeah, exactly. It suggests that our thoughts, they can go beyond the limits of language. It's a really complex interplay between language and thought, how language can both reflect and shape our cognitive processes.
It makes me wonder if, like, learning a new language could actually change the way you think. Have you experienced anything like that?
That's a question that really fascinates both linguists and cognitive scientists.
Okay.
There is some research, suggesting that learning a new language, it can make you more cognitively flexible and even improve performance on tasks that need executive function.
Right.
It's like the brain's working out new pathways.
That's interesting. So as we wrap up our look at this 1997 snapshot of cognitive science, what are some of the big takeaways for you?
I think what strikes me is how much of what we know about the brain comes from these early theories. Even though some of the research might seem, well, a bit old now, these were the pioneers, asking the fundamental questions that still drive the field today. And just as important, it reminds us that, that the journey of understanding the mind, it's far from over.
This has been a fascinating look at some of the foundational concepts in cognitive science.
Yeah.
But our time machine, it isn't done with us yet, is it?
You're right. We've covered the big picture, but next time we'll dive into the nitty-gritty of cognitive processes. How our brains handle attention, memory retrieval, and problem solving.
Sounds like we're about to zoom in on the inner workings of the mind. Can't wait. All right, welcome back to our final descent into this 1997 cognitive science time capsule.
It's been quite a journey from those big theories to the details of language.
Yeah, it has. I'm ready to tackle these final entries. What else do we have?
Well, let's focus on the mechanisms, the nuts and bolts of how we think. The entry for attention, for example. It reminds us that this, seemingly simple process is actually super important for almost every cognitive task, from learning to problem solving.
Right. It's like the mental spotlight.
Exactly.
The one that shines on the information we need.
Right.
But it's more than just passively taking in information, right?
Right. The dictionary really stresses that attention is active. We're
Yeah.
always selecting, filtering information, choosing what to focus on. It takes effort.
That makes me think about like all the distractions we have now. Our phones, the internet. It's amazing we can focus on anything.
It is. It shows how adaptable our brains are. And the dictionary also talks about different types of attention, like attention getting, attention holding, and attention releasing.
So there's not just one like attention button.
No, it's a whole system. Attention getting is how we notice important things. Attention holding, that's how we stay focused, even with distractions. And attention releasing is how we disengage and move to something new.
It's like our brains are constantly juggling.
Yeah, exactly. Constantly adjusting to what's going on around us. Speaking of juggling information, let's look at memory retrieval. Now, the dictionary defines it as, getting things back from memory, which sounds pretty simple, but I'm guessing there's more to it than that.
I bet.
Right. Memory retrieval is anything but simple. It involves, a lot of different brain regions and mechanisms. Our memories aren't just filed away neatly. It's more like this huge network where each memory is encoded in a in a specific pattern.
So how do we actually pull out a specific memory?
The dictionary emphasizes the role of cues and associations.
Okay.
When we're trying to remember something, our brains use cues, little bits of information, to start a search process.
It's like one of those games where you get clues to find something.
Right. Exactly. And the more cues we have, the easier it is to find the memory. That's why, it's easier to remember things when we're in the same place where we learned them, or if we have reminders.
And it makes me think about like the power of associating things. If our memories are linked together, then activating one can trigger a bunch of others, right?
Absolutely. One memory leads to another, creating these chains of associations. And it's this web of knowledge that lets us make connections, figure things out, and build on what we know.
Okay, last one. Problem solving. The dictionary calls it finding solutions to obstacles. Again, pretty straightforward, but I bet there's more to it.
Of course. The dictionary talks about the tools we use in problem solving, things like heuristics and algorithms.
Right. Remind me again the difference.
Well, an algorithm is a step-by-step process, like a recipe.
Okay.
It guarantees you get the solution. A heuristic is more like a rule of thumb.
Right.
It helps you make decisions faster, but it doesn't always guarantee the best outcome.
So in everyday life, we're using heuristics a lot.
Yeah. They help us deal with a complicated world, but the dictionary also points out they can be tricky.
Oh, okay.
You see, because they rely on assumptions, heuristics can lead to biases, especially in new situations.
So it's a balance between being quick and being accurate, right?
Yeah, exactly.
Our brains are always weighing those two things.
Well said. Well, this brings us to the end of our journey through the 1997 Cognitive Science Dictionary. What are your thoughts?
It's remarkable how much this dictionary covers. It's like we've been digging through the foundations of cognitive science. And while some of the terms and theories might seem a bit old now, it's really fascinating to see how these early researchers laid the groundwork for what we know today.
I agree. It reminds us that science is a process. We're always discovering and refining our understanding. The questions they were asking back then, well, they're still relevant now, even with all the advancements we've made.
And it shows how much we still don't know about the brain. Every answer seems to lead to even more questions.
Yeah, and that's what's so exciting about cognitive science. It's a field that embraces the complexity and pushes us to keep exploring and questioning.
Well, thanks for joining us on this deep dive into the 1997 Cognitive Science Dictionary. We hope you've enjoyed this journey into the incredible world of the human mind.